This video will cover 1-4, 1-5, and 1-6, the identity and equality properties, as well as the distributive, commutative, and associative properties. Please copy all of the definitions as well as the examples for each of the properties. The first property is the additive identity. This property states that when you sum or add a number and 0, you will always get that number. So if we take, for example, a plus 0, we're going to get a. Or for another example, if we take 8 plus 0, we'll get 8. The next property is the additive inverse. When you take two numbers and add them together and get 0, this would be the additive inverse. And an example of this would be if we take a plus a negative a, we'll get 0. Or if we take 5 plus negative 5, we will also get 0. Don't be confused with this. If we take 5 and we subtract 5, we also get 0, but this is not an example of the additive inverse. The multiplicative identity, or the product of any number and 1 is equal to that number. So, for example, if we take a and we multiply it times 1, we'll get a. Or if we take the number 3 and we multiply it times 1, we'll get 3. The next property, the multiplicative inverse, is when two numbers whose product is 1. This is an example of multiplying by the reciprocal. So, the easiest way to show this is as fractions. If we take a over b and we multiply it by b over a, we'll get an answer of 1. B over a is the reciprocal of a over b. By multiplying by reciprocals, we'll always get an answer of 1. So another example of this, if we take 2/3 and we multiply it by its reciprocal of 3 over 2, we get an answer of 1. The reason that we get the answer of 1 is that when multiplying fractions, you can always reduce any top number with any bottom number. So on the top here, we can reduce this 2 with this 2. They both reduce down to 1. Same thing with the 3 on the top and the 3 on the bottom. They both reduce down to 1. So our answer is 1. Another example of this would be if we take the number 5 and we multiply it by 1 over 5. Remember that the number 5 written as a fraction would be 5 over 1. So its reciprocal would be 1 over 5. And then if we multiply those, we'd get an answer of 1. The top 5 would reduce with the bottom 5, and we'd get an answer of 1. The next property, the multiplicative property of 0, is anytime we multiply a number by 0, we'll get an answer of 0. So a times 0 will give us an answer of 0. Whoops. Or 8 times 0 will give us 0. The next property is the reflexive property, stating that any quantity is equal to itself. So a will always be equal to a. The symmetric property, however, states that if a is equal to b, then b is equal to a. So all they're doing here is they're saying, well, it doesn't matter what's on the left side and what's on the right side. I can write x equals 2, or I can write 2 equals x. The equal sign is just showing that both the left and the right are of the equal quantity. The transitive property states that if a equals b and b equals c, then you can conclude that a also equals c. So, for example, if 4 plus 1 equals 5, and 5 also equals 2 plus 3. Well, then we have to know that 4 plus 1 is the same thing as 2 plus 3. Then the substitution property just states that any quantity may be substituted in for its equal value. So if we have something like 6 plus 1, we can substitute the value of 7 in for 6 plus 1 at any time. The distributive property is a way of simplifying an algebraic expression where a number or variable is multiplied on the outside of parentheses. For example, if we're given A times B plus C, this can be simplified by distributing the A to both the B and the C. Now A is multiplied, so we do A times B, which gives us AB, and then we do A times C, which would give us AC. Another example of this would be to take 5 times G minus 9. So first we'll distribute the 5 to the G. This gives us 5G. Now we distribute the 5 to the negative 9. 5 times negative 9 gives us a negative 45. Here's one more example. 3 times x to the second plus x minus 1. Now we'll be distributing a 3 to each of the 3 terms on the inside of our parentheses. 3 times x squared gives us 3x squared. 3 times the positive x will give us a positive 3x. And 3 times the negative 1 will give us a negative 3. Here in our last example, we'll be taking a negative 6 and we'll be multiplying it times r minus s minus t. Pay attention to the signs on this one. We'll be distributing a negative 6, so negative 6 times r is a negative 6r. Negative 6 times negative s, well, a negative times a negative gives us a positive, and 6 times s will give us 6s. Negative 6 times negative t will give us a positive 6t. Be careful on the signs here. Every single time we multiply, we're writing the answer with the new sign. So a negative times a negative here will give us a positive 6s. Like terms are any term that has a variable brought to the same power. So given 3a squared plus 5a squared plus 2a, the 3a squared and the 5a squared are considered like terms because they both have an a brought to the second power. Like terms can be combined by summing the coefficients. So 3a squared and 5a squared sums to 8a squared, and we also have that plus 2a. Now 8a squared and 2a are not like terms, so this cannot be simplified, and this would be your answer. Here we go. The last two properties are the commutative property and the associative property. The commutative property states that the order in which you add numbers or multiply numbers does not change their sum. So if we add 1 plus 2 plus 3, we'll get 6. If we change the order, simply 3 plus 1 plus 2, we'll also get 6. The associative property states that the way in which you group numbers does not change the sum or product. So if we group, let's take the same first example. If we group the 1 and the 2 together, this will still give us an answer of 6. However, if instead we group the 2 and the 3 together, we as well will get a 6 here as our answer. 1 plus 2 is 3, plus 3 is 6. 5 plus 1 is also 6. Remember that this works for multiplication and for addition in both of these properties.